Thanks a lot for having me again. I'm a veteran. I'm the second time at this conference. Thanks a lot. Okay, I'm a junior veteran. I'm principal consultant, business development, as I would call it, at SBB. I'm currently engaged in the S/4HANA transformation program at SBB and responsible for the asset and maintenance management process scope. I took the red badge and I left the jacket at the table because I built a coherent with the two guys on the roof of the train set. I think what I would like to talk about is really that whatever we do when it comes to asset and maintenance management, it has to have an effect on our assets so that they work reliably, as it has been said already. And in the end, for us, as an operator as well, it's very important that the effect is shown with the end customer, which is the passenger traveling with SBB. I have quite some slides taken with me, but today I'm going to talk about one use case that I think is very insightful. It's about the sliding strip, as we call it, on the top of the pantograph, which interacts with the catenary line. So from there, we take the electrical energy for the train and activate the motors that drive the train. And it's about getting better there, supporting the two colleagues on the roof, that whenever they go onto the roof, that it's only because they really know they have to change something, or what they inspect is really something they need to do so that it has an effect. I quickly introduce SBB for those not knowing SBB. We have around 30,000 employees. We are organized in different divisions. We are an asset-heavy company, and we are organized in the division for infrastructure. So that means the rail network, the energy network, the water network, and of course, the telecom network. So we provide our own telecom services. Then we have the passenger services production. They are dealing with all the rolling stock over the complete life cycle of the rolling stock. We have a real estate division with a lot of assets, the buildings with the facilities in there. And there are some others, among them also cargo freight division, a lot of rolling stock to transport freight. And in our strategy at SBB, that has been reformed with the new CEO. It's the strategy for SBB for 2030. There is a success factor addressed, and that success factor is called also asset management, and maintenance is part of the asset management process, if you want. I will talk about that because I think it's important to understand where prediction in the end brings in a benefit. In our S/4HANA transformation program, which I quickly want to address, it's not kind of out of scope here because it gives you an idea on what we do in maintenance optimization shall have an effect not only for rolling stock but all the other assets as well. The program is organized in different process scopes: finance, procurement, project portfolio management, and also, and very important, and that's my responsibility, it's the enterprise asset management, which includes the 4 asset clusters: rolling stock, networks, facilities or buildings, real estate, if you want. And we have built a virtual cluster, which is addressing all the production means that we have in the facilities, lathes, cranes, etc. And all these assets, we want to manage over their life cycle according to a standardized process. And that process looks something like that. That means that's on level 2. So it's addressing more or less a life cycle. And predictive maintenance addresses multiple of these processes here. For instance, the maintenance strategy, the third one, is very important, that we have an idea how we want to manage our assets over their lifetime. So is it a run to failure strategy? Is it preventive? Is it condition-based maintenance? Does it take benefit of prediction? You will see that it's not either one. It's usually a blend, like a good whiskey. It's a blend of maintenance approaches for one specific asset or a component even. Huh? And in the end, the two guys that are standing on the roof, they're part of that maintenance execution. Huh? So they are executing according to their task list and work plan. And if you put that in a loop, you understand that it's not from left to right and then it's finished. No, it's never ending. It's a part of an optimization process, and it's important that the guys on the roof can give feedback to those that define the strategy for maintenance. Huh? We have some challenges. That's one. McKinsey was at SBB visiting us in 2016. And I didn't bring up that slide for years, but now I started to reuse it because I think it's very insightful that we need to understand and learn from the data that we already have. And you often hear people saying we don't have enough data or not the correct data or it's not valid or whatever. But I think if we take what we already have and use it and bring it together end to end to have an effect in the life cycle of the asset, then we will become better and better. And it was regarding maintenance here, and that addressed especially the concept on how we define maintenance strategies. And one lesson that we learned there, and that was my role when I was at the rolling stock department in 2018. I had the chance to define and introduce a business strategy for optimizing the maintenance of our rolling stock assets, especially the new train sets. And we decided there, after a year of stealth mode, at least I found then people that followed the idea and the vision to introduce RCM as a concept, which means something that the aviation industry executes for 50 years already, will finally also come into the rail industry. We heard about design FMEAs and stuff like that. The knowledge is there, but it's not properly connected and not exchanged between manufacturers and operators. And what I'm talking about here is an operational failure mode analysis, failure mode and effect analysis that is the foundation for everything we're talking about here. It's about optimizing the maintenance on failure mode level. So maintenance is managed on failure mode level. Point. That means what I just mentioned, it's usually a blend of strategies or different types on how you try to define the task that prevents a failure mode to occur. That can be, if you can decide on a run to failure strategy, then that's because you evaluated the risks already and you made sure in that analysis that it doesn't affect someone that then dies, for instance, from operating the asset or using it. That means for different components, and we defined what are the relevant components, we decided to go for a really time-consuming RCM analysis. So that's something you do in workshops with a lot of cohorts, people that come together from different disciplines, and you organize a workshop, and then you define from scratch, from the maintenance manual, from the learnings, from the operation, from the overhaul, etc. You define the maintenance strategy for the specific components that are relevant, either for cost, for punctuality, or for customer comfort with us. That were the three reasons why we decided these and some more systems. So that's a new slide. I try in every speech to bring a new slide. That's one. I'm not sure if it's good, but I'll try to explain. When it comes to condition monitoring, that's not always a sensor. That sensor could also be a person, smelling, like listening, touching, measuring. Here it's about the pantograph and the sliding element, and there we send the two guys onto the roof to measure with a tool if the strip, if that tool fits over the strip or not. That's how they decide. But the discussion here is, how can we automate that? How can we build a system that measures more often, maybe even more precise, but specifically registers the data in a system so that we can use that data to learn from that data and take decisions in the end in the business. There are other failure modes that can be described, but I think here we decided to go for the thickness in the middle. We know the thickness along the complete length, but we decided to go only for the thickness in the middle and build a serious data stream of that. So that means if we know where it takes effect in the process, if we know where we tune the capabilities in the organization, and if we know which IT system supports these capabilities in that process, we know a lot already. Then we build an architecture. And here it's only important on that slide that you understand, I think it's also a closed loop to learn from the checklist results from the maintainer and feedback that into the system, the ERP, the enterprise resource planning, or you have condition-based data that you pre-process in another system. We call that enterprise analytics platform. And then you feed it into the ERP. And I think that feeding into the ERP is very important. We don't need real time. We are triggering business processes. We are triggering alerts, maintenance notifications, or we can even trigger maintenance tasks. But it's not triggering a machine in real time to change something in the operation. And we can also feed back to maybe some manufacturers or OEMs and hand over that data to them, and they pre-process it with their own knowledge. It could be Hitachi or Alstom, as we learned, and integrate that back in our process. I think we are not yet there, but that's where we should go. There are a lot of use cases, and it's my talk here is like, don't wait, start now, and start with what you have. Start with the people you have, but go on and iterate and try to become better on whatever. Here it's all about things we learn about water tanks, pantograph, or wheel sets. That's our golden case. That's where we do prediction already. And when I say don't wait, start now, it's about elaborate, have an innovation funnel, try to motivate your people to change the system where they think the organization has a flaw. Then discuss about it. Is it about technology? Is it about organization? Is it about process? Is it about data? But you need to be able to elaborate. But then the hard one is to transfer and industrialize your proof of concept into the operation. And that pantograph is the story about doing that transfer into the operation. The Pantograph scanner is a camera and a flash, trackside, fixed, mounted, in the position of the yellow area, as you see it there, more or less on such a similar gate. And we have one prototype at the moment that is installed and where we derive our data from. And it took us years to understand what position is the right one, what camera, what flash, how do we take the pictures in what direction. And we learned we don't need 3 cameras or 7 flashes. We just need 1 camera, 1 picture. That's it. So what do we do? And here could be a slide about algorithms. I published the 2 algorithms that we trained on Hugging Face. The keyword is Panto-Scanner. You can go there right now and have a look. We use YOLO 5, which is long time ago. It's 8 or 9. I don't know what actual version we have, and DeepLab. So to detect and segment the sliding strip. And from there, we measure the thickness and derive the thickness in the middle. That's a visualization in our system that is provided by the rail infrastructure division, who operates the gates. And we take the pictures from there. We apply the algorithms and we feed back the measurement so that you can visualize thickness in operation. That's already working. And this is nearly the last slide. That's all about it. How these 2 guys on the roof will receive their planned order, work order in a manner that they already know. This is an implementation in S/4HANA APM. It's Asset Performance Management. That's the solution we have decided to use. The goal here is to really display, also show the indicate monitoring, as we call it, for the 2 sliding strips of that specific train set to the maintenance planner, who can have a look at the data. And what you see here is the first time that we see it. It's a life cycle of the sliding strip. And so we learned a lot on that journey until here. I think one thing to mention is also an influencer ticket that we handed over to SAP, because the guy in the workshop in Lucerne, he said, if I press on that point there, I want to see the picture. And so we formulated like a feature request, and in October, you will see that by SAP in the standard solution. So that means we can also influence our software provider. And with that, there will be integrated some loops, also the man in the loop that can give feedback to train the algorithm and give feedback to the algorithms. So that's my last slide. It was a lot about failure modes. I think that's something, a keyword I would like to give to the audience here. Look at Nolan and Heap, 1978. It's the Bible for reliability management. And it's about improvements in the organization. I think innovation is very important, that you have also in an organization that does operation, that you have an innovation culture. That's very important. It's also about enterprise architecture, process, data, IT architecture, capabilities. That's very important. And I think if you have that framework, implementing AI or the machine learning is easy. If you have colleagues, partners like EPFL and other universities that do such a good job. But I think it's a lot in the organization that has to be changed, that a framework is there that we can implement such things. And in the end, it is important that it has an effect in the business. Thanks a lot.